Okay. Leo tutaenda kuangalia kipengele cha reaction from a jet engine pamoja na rocket propulsion, ambapo mainly hizi zinakuwa governed na Newton's third law of motion. Newton's third law of motion. Okay, tuanze na reaction from a jet engine. We say that the operation of a jet engine depends on the third law of motion, where the escaping mass of hot gases exert force on jet, enabling it to move forward. Air is first sucked through the front side, then compressed. The oxygen contained in this air intake is used in burning the fuel producing gases, which when expelled at a very high speed through the reaction force are created and hence forward thrust. Concept kubwa tunayoipata hapa ni nini? Kwamba jet engine za ndege ambazo zinakuwa zina operate, principle yake ni katika third law of motion. Maana zile engine zinakuwa zimetengenezwa ambapo zikiwa zikishawashwa zinakuwa zinafanya kusuck, air is sucked in through the front side, then compress. Maana zinanyonya hewa ndani ya zile engine, then zikishanyonya zinai-compress. Zikisha compress tunasema kwamba ile oxygen ambayo inakuwa intake is used in burning the fuel. Kwa hiyo kuna fuel ndani ya engine inakuwa burned, then ikisha kuwa burned maana yake kuna hot gases. Hot gases are produced, and when these are expelled at a very high speed, ndio hicho tunapata thrust, tunapata force ambayo inakuwa inasukuma ndege kwenda mbele, kama inakuwa inasukuma ndege kwenda mbele, forward. That's the meaning of it. Let's see some related concept. You say that principle of a jet in which the mass of air is taken in is at the rate of maanake ni rate ya mass of air. Rate means something per time. Rate of mass of air to be taken in, maanake ni kitu ambacho tumezungumza hapa kwa sucked, maanake ni dma over dt. Maanake ni this is the rate, maanake ni change of mass of air per time, change of mass of air per time. But remember, this mass of air is the one which is sucked through the front side of the jet engine. Then this mass of air sucked, we say that it's have some relative velocity. Kuna velocity of air pale maybe a meter per second. Then ikishakuwa sucked, we say that it passes through the engine at the rate, yani manake mass of air sucked inapita pia kwenye engine katika rate hiyo hapo. dma means this is the change of mass of air per time with the velocity v, maanake ndani inakuwa ni velocity. This is the velocity inside the engine. This is the velocity inside the engine. This is the velocity of air. Maanake this is the velocity of air inside the engine. This is the velocity of air outside the engine. So the rate there is dma over dt, which is measured in kilogram per second with the velocity v. Then we say that in mass of gases mg produced, kwa sababu tumesema kwamba we have this one is producing fuel producing gases. Then mass of gases produced, we call it mg, is produced at the rate of mg dmg dt. Maanake ni change of mass of gas per change of time, change of mass of gas per change of time. I would say that by combustion is ejected at the relative velocity v. Then the total rate of change of momentum of the system is therefore given as, maanake ni baada ya hapo sasa momentum, ambapo change of momentum ambayo take place hapo ni hivi kwamba tutakuwa tuna initial momentum na tutakuwa tuna final momentum. Our initial momentum is this one, dma dt. This is initial momentum, this is initial momentum. Final momentum ni hapa kwamba ni mass of gas pamoja na mass of air. Ukichukua mass of gas, the rate of change of mass of gas plus rate of change of mass of air, this is final momentum. This is final momentum minus initial momentum, which is the rate of mass of change of air. Kwa hiyo maana yake hapo tutapata ni dp dt, which this one is standing for momentum. Na kumbuka kwamba tunasema kwamba the rate of change of linear momentum is directly proportional to mass, to the applied force, which equals to mass times acceleration. Mean that this dp dt is what we call it a thrust. This is a force. This is a force. Kwa kupata force ambayo itakuwa driven by the engine za jet ni uchukue initial final momentum, this one minus initial momentum, kwamba uchukue rate of the gas produced plus rate of the mass of air then minus the rate of the mass of air initially. Kwa hiyo utapata kitu kama hicho hapo. Then our concept can be explained by this concept, by this diagram. Here we have jet engine, mean that this is air sucked to the combustion chamber, from which is mixed with the oxygen. Then the hot gases are produced. Then after being produced, they are expelled. Hot gases plus air. Remember here the air is sucked in, then the one which is expelled is hot gases and the air with a certain velocity v. Then we say that from Newton's second law of motion, the rate of change of momentum is equal to the force, or we call it applied force. Therefore, equation 4.39 mean that this equation here, we say that it represents the forward thrust on the jet aircraft. I will say that some jet aircraft have 2 identical engines and others have 4. The total thrust is the product of number of engine and the thrust of one engine. Manake ni kwamba kuna baadhi ya ndege zina engine 2 na zingine zina engine 4. Manake hii ni force ambayo inakuwa produced na engine moja ya ndege. Kwa kama ndege na engine 2, manake you will multiply by 2 this one. Kama ndege na engine 4, you will multiply by 4, then you get the total thrust provided by the engine. Okay. Let's see now the reaction from a rocket. Tuangalie reaction from a rocket ambapo ndio kipengele cha rocket propulsion tutakipitia hapo pia. I will say that unlike the jet engine, the rocket carries all of its propellant materials including oxygen with it. Maanake ni tofauti na kwamba ndege inakuwa inategemea oxygen katika surrounding, lakini rocket yenyewe inakuwa inabeba oxygen kwa sababu sometimes na rocket inaenda katika anga za juu ambapo kunakuwa hakuna oxygen. Kwa hiyo huwa inabeba we call it propellant materials, ambapo we say that it include oxygen with it. Okay, we say that imagine a rocket that is so far away from gravitational influence of the Earth, then all of the exhaust hot gases will be available from the propelling and the accelerating the rocket. Figure 4.2, tutaiona hiyo figure. We say that it shows an illustration of a rocket of mass m carrying the fuel of mass change of m, such that the total mass at the time t is m plus change of m. Maanake ni kwamba mass hii ni mass ya rocket, hii change of m ni mass ya fuel. We call it change of m kwa sababu hii mass ina tend to change. Maanake rocket inavyoanza hii mass huwa inapungua kwa sababu there are some gases are burnt, mean that mass ina tend on decreasing. That's why you call it the total mass is m, which is the fixed mass ya rocket na mass of the fuel carried. Then we say that for instance this part, this rocket moving horizontally far away from the Earth's surface. As the fuel burns, and gases formed expelled from the rocket at a velocity of vg after some change of time, the mass of the rocket becomes m. Maanake nini? Kwamba fuel inapokuwa inaungua, haya mafuta yanapokuwa yanachomeka pale, na gases zinakuwa expelled kutoka kwenye rocket, velocity ya gases ambazo zinakuwa expelled we call it vg. Na after some time, manake after change of time t, mass of the rocket becomes m. Manake it will reach a time kwamba this mass will, because this is change on decreasing, so mass will remain m, but velocity yake ita increase. Velocity ya rocket itafanyaje? Ita increase. The more fuel is burnt, the more velocity of the rocket increases. Let's see. Velocity will increase from v plus change of v, mean that this will tend on increasing. Hii velocity ya rocket ya kawaida ya mwanzo, lakini itakuwa ina increase with change of v, as the figure hapo taona. Asema the velocity of the ejected gas decreases. Na velocity ya ejected gas ita decrease from v to change of v. Manake velocity of the gas, the more fuel inavyokuwa burnt, velocity inazidi kupungua, maana fuel inaisha. Kwa hiyo velocity itakuwa na change from v to change of v, lakini velocity ya remember these are the hii ni v ni velocity ya rocket. Kwa hiyo itakuwa na relative. This is tend on increasing, Kwa sababu gani? This is the result of motion ya rocket. Hii ni result ya motion ya fuel burnt, velocity yake ita tend on decrease. Kwa hiyo the simple illustration this one mean that we have mass plus change of mass, then we have mass. This is v, initial at time t is v, na hii vg ni velocity of the hot gases expelled, velocity of the hot gases expelled. The rocket then will get v plus change of v, mean that the velocity of rocket initial was v, the velocity at the mass of the exhaust gas decreases, the velocity of the rocket will increase from v to change of v. And then you say the rocket propellant at time t, given that one, this is a rocket at time t plus change of time t plus change of time, maana baada ya muda fulani total time ikiwa ni rocket imeshaondoka, kwa inakuwa katika namna kama. Then tunasema from the principle of conservation of linear momentum ni kwamba hivi tutakuwa tuna initial momentum. Initial momentum always equals to final momentum. Initial momentum yetu itakuwa nini? Mass times change of mass times velocity ya rocket. This one will be equals to change of mass ambaye ni pale mass za the fuel zinapokuwa na decrease, it will be v minus vg, then tutajumlisha mass of the velocity, mass of the rocket, momentum of the rocket, it will be mass plus v plus change of v, from which if you open the bracket you'll get mv plus v change of m equals to v change of m minus vg change of m plus mv plus m change of v, from which this will be cancelled with that one, also this will be cancelled by that one, then remain with him m change of v minus vg equals to 0. Maana tunapata nini? Kwamba uchukua mass of the rocket, change of the velocity of the rocket, ukitoa mass of the hot gases expelled, ukazidisha na change of the mass of the gases will be equal to 0. Maana nini? Mass of the rocket times change of velocity is sana mass of the gas times change of the mass of the hot gases. This is the mass of the hot gases. Hence, simply we say that change of the velocity of the rocket will be equal to velocity of the gas over mass of the rocket, then times change of the mass of the hot gases over change of time. Hii ndio equation yetu ya msingi. This is our basic equation. This is our basic ambao uki divide by m both sides then divide by t, unapata kwamba m dv dt will be equals to vg dm dt. So this is our basic equation. Hii ndio basic equation katika rocket propulsion. This is our basic equation on the rocket propulsion. This is our basic equation. Then we say that since the rate of change in momentum is equal to the thrust or force of the rocket by escaping mass of the gases, the above relation can be written as mean that the force will be equals given by velocity of the gas, hot gases, change of mass of the fuel per time, rate of change of mass of the fuel per time. Maana hii ni forces. The force of the rocket inakuwa given by this one, force of the rocket inakuwa given by that one, but expression yake tumeshaiona hapa juu kwamba this mass times the velocity which this is acceleration, ndio hichi kitu ambacho tunakizungumzia hapa. Then we say that if the large thrust is to be obtained, the rocket designer has to make the velocity vg at which the hot gases are ejected and the rate at which the fuel is burnt high as possible. Sasa concept yetu iko hapa kwamba rocket ikiwa moving vertically, sasa you have to subtract mass times gravitation mg. Mean that the basic equation here will be equals to, from this one equal to that one, you have to minus mg. Kwa hiyo concept ya rocket propulsion ndo hii hapa. Concept ya rocket propulsion ndo hii hapa, kwamba kupata force, this is stand for force, equals to velocity ya gases ambazo zinakuwa expelled, hii ni rate ya mass ambapo zile hot gases zinakuwa burnt, then minus weight, mass of the rocket times gravitational constant, then you get the force. Kutokea hapo unaweza ukapata unknowns yoyote. Unaweza kauliza sometimes find the rate, find the velocity of the gas expelled, then you can get it. Then from there this portion will end there, but you can attempt this example. You can attempt this example for your own. Then we shall end there this time until next time. Try to do this example 4.8. You say that the engine of a jet flying at that one takes that one in air per second and operating height at which the density of air, that one, the air is used to burn the fuel at the rate of the exhaust gas, including the incoming air are ejected at that one relative to the air, determine the thrust. Thank you so much. Have a nice time.